Alright, let's go. Inside the event horizon of a supermassive black hole. In April 2019, the Event Horizon Telescope collaboration released the first direct image of a black hole's event horizon, the point of no return surrounding M87's supermassive black hole, 6.5 billion times the mass of our Sun, located 55 million light-years away in the Virgo cluster. The image showed a ring of light surrounding a dark center, photons desperately orbiting at the last possible stable orbit before being dragged across a boundary where physics as we understand it fundamentally breaks down. What the image couldn't show, and what no image ever could show, is what lies beyond that glowing ring, where the laws that govern reality admit their own failure to describe what happens next. Black holes were first predicted in 1916 by Carl Schwarzschild while solving Einstein's field equations, but for decades they remained mathematical curiosities rather than physical objects. The idea seemed too extreme, a region of spacetime where gravity becomes so strong that not even light traveling at the universe's speed limit can escape. By the 1960s, observations of X-ray sources like Cygnus X1 provided strong evidence that stellar mass black holes exist. Discovery of supermassive black holes at galactic centers, including Sagittarius A* at the Milky Way's core with 4 million solar masses, revealed that black holes range from a few times the Sun's mass to billions of times. The 2019 image represented the culmination of decades of theoretical prediction and observational astronomy. The event horizon represents a boundary in spacetime, beyond which escape becomes mathematically impossible. At this surface, the escape velocity equals the speed of light. 1 meter beyond it, escape would require exceeding light speed, which physics prohibits. But the event horizon is not a physical surface, it's a mathematical boundary in the geometry of spacetime itself. For an outside observer, time appears to stop at the event horizon due to extreme gravitational time dilation. You would appear frozen at the threshold, your image red-shifted and dimmed, taking infinite time to cross. But from your perspective, you would cross in finite time, noticing nothing special about the moment you pass the point of no return. What makes crossing the event horizon truly terrifying is what happens to causality itself. In normal spacetime, you can move freely in 3 spatial dimensions, but are dragged inexorably forward in time. Inside the event horizon, this changes. The direction toward the singularity at the black hole's center becomes time-like rather than space-like. Just as you cannot avoid moving forward in time under normal circumstances, inside the event horizon, you cannot avoid moving toward the singularity. Every possible path, every future trajectory leads inward. Forward in time and inward in space become the same direction. The singularity isn't just somewhere you're falling toward, it's in your future, as inevitable as next Tuesday. At the singularity, general relativity predicts infinite density and infinite curvature of spacetime. But these infinities signal that our theory breaks down rather than describing physical reality. What actually exists at the singularity remains unknown, because quantum effects, which general relativity doesn't account for, should become relevant at such extremes. Proposed quantum gravity theories suggest various possibilities, wormholes, fuzzballs, Planck scale structures, but we have no way to test these theories. The singularity might not be a point at all, but something our current physics cannot describe. Stephen Hawking proved in the 1970s that black holes should slowly evaporate through quantum effects, implicating a final explosion. But for a supermassive black hole, this process would take 10 to the 100th power years, incomprehensibly longer than the current age of the universe. Inside the event horizon of a supermassive black hole, causality itself breaks down. Every direction you could move, every path you could take, leads inward toward the singularity. The universe you knew continues existing outside, but you can never receive information from it, never affect it, never escape. You've crossed into a region where the future is spatially located, where time flows toward a point rather than a moment, where the equations that describe reality produce infinities and division by zero. This isn't just a place you shouldn't visit. It's a place where the very concept of place loses meaning, where physics admits its failure to describe what happens next, and where every human reference point for existence dissolves into mathematical uncertainty. Black holes represent the ultimate boundary of the knowable universe, and crossing that boundary means leaving behind the realm of physics. We can test and entering a domain where even asking, "What happens?" may be a question without meaning. They are the final terrifying reminder that the universe contains regions where the rules that govern existence simply end, replaced by something our minds and mathematics cannot yet comprehend. If you want to see more videos like this, click the video on screen now and make sure to subscribe.